Hey all, and welcome to your last lesson in Chapter 5, which we're going to look at word problems. If you have any problems from earlier that you want to nominate in the homework forms that you want to see answers for, especially as a study tool to help you with the test, please do that, and I'll keep looking at those, figuring out where I can help you all master these topics. And of course, if you get stuck on any of these problems as well, nominate them in the homework form, and then I will attach a video and send out a class comment that the video is ready to be viewed. So get yourself ready for notes. We're going to talk about word problems with harmonic motion. And harmonic motion here just means that you're going to use the function sine or cosine, just depending on whether it's starting at sort of the origin, if it's starting at neutral, or if it's starting at a maximum or a minimum. Now, in terms of word problems, we have a little bit that we want to think about with amplitude, period, and we're going to introduce this idea of frequency. So amplitude is, again, A in the function. And in a word problem, this can mean height of something. It can also mean displacement. And displacement is movement from neutral or from the center. Now your period, as you've thought about this before, this is 2 pi over k. And this is, in terms of these problems, think of this as the wavelength. Now we're introducing this other idea of frequency, which is actually the reciprocal of period, so it's k over 2 pi, and this is the number of waves per unit of time. So if you plug this in and I say, oh, how many waves are there in 10 minutes? If the problem's in minutes, that's just a frequency question of time. If the problem's not in minutes, you can convert your units of time. I believe in you. So these are the new ideas here. So for number one, the carrier wave of an FM radio signal is modeled by the function y is equal to a sine 2 pi times 9.15 times 10 to the 7th t, where t is measured in seconds, right? FM radio is frequency radio versus AM, which is determined by its amplitude. So that's why A here is just a constant, because FM, it really cares about the frequency. It doesn't care all that much about the amplitude versus AM radio. So, find the frequency, period and frequency of the carrier wave. So, what remember we're going to do is that K is everything that's multiplied by the variable. So, in this case, T is our variable, and everything that's multiplied here is equal to K. So, K is equal to 2 pi times 9.15 times 10 to the 7th. Now, the nice thing with this 2 pi is we know it's going to simplify out nicely. So, in this case, we've got our period is equal to 2 pi over 2 pi times 9.15 times 10 to the 7th. So that cancels out nicely there. And since this is our lovely scientific notation, I can think about this separately as 1 over 9.15 times 1 over 10 to the 7th, which in terms of scientific notation, I'm going to, there we go. I'm going to rewrite as 10 to the negative 7th. Then 1 over 9.15 is equal to 0.19, let's see, 0.1093 times 10 to the negative 7th. Move that decimal one spot because the number's too small, so we subtract 1, and we get the period is equal to 1.093 times 10 to the negative 8th. And this is the wavelength. The frequency is the reciprocal of this, so 2 pi times 9.15 times 10 to the 7th over 2 pi Frequency, again, cancels out nicely, and we're just left with 9.15 times 10 to the positive 7th. So here's our frequency, and here's the period. Now, a really common harmonic motion problem is springs. So an object is attached to a coiled spring, like we see here. This is our resting position. It's pulled down 5 centimeters from its neutral position and released. It takes 0.8 seconds to travel from the longest spring to its minimum height. So it goes, you pull it down, you release it, it goes back up to here, and then it's going to come back down, and it's going to oscillate like this. Write the function for this object's motion. So what this tells us here in this problem is this distance is 5 centimeters from neutral, and what that gives us is our amplitude. So amplitude, nice, straightforward, 5 centimeters. Now the other thing we need to find is K, and then we have to determine if it's sine or cosine. So if I look over here at this graph, I can see that I am down here. I am starting at an extreme point. So if you start at a minimum or a maximum, that means that you're going to use cosine. Alternatively, if you start at neutral, that means that you're going to use sine, because remember, sine starts here and cosine starts at a minimum or a maximum. And since it's a minimum, so what this tells us is that we also start at a min, so we want A to actually equal -5. And we know that we're going to have, and that's going to tell us cosine. So what this we now know is f of x is equal to -5 cosine of kx. So all we need to do is find k. Now we know the period is equal to 2 pi over k. And if you look here, we're given the information that this time from the minimum to the maximum is 0.8. Now this is half of a wavelength. The full wavelength is when it comes back down to the bottom again here, which would be 1.6, is double this distance. And so what we know here we can solve for is we know that the period is 1.6 seconds. We know, therefore, that 2 pi over k is going to give us our equation. So I'm going to multiply by k and divide by 1.6. So k is equal to 2 pi over 1.6, which I am going to simplify as 20 pi over 16. Simplify that fraction as 5 pi over 4. So therefore f of x is equal to -5 cosine of 5 pi over 4x. And that's our function. If you have questions about the word problems, please reach out over Zoom, email, or nominate them in the form, and I'll look forward to talking to you all before your test next week.